Every matrix has a number. That number is called the determinant of the matrix. This is an example of a 2x2 matrix, 2 rows, 2 columns. Matrix is indicated using these brackets. However, because every matrix has a determinant, we use these bars to indicate the determinant. Now, the determinant is a number. Think of it like a blood test. When you go and you get a blood test regarding your blood pressure, for example, you get a number. And that number tells you something about your health, maybe. So the determinant is just a number. How do you find that number? Well, you basically take the diagonal and you multiply them together. And then you subtract their products. And that's how you find the determinant. So there is a matrix that's composed of 3, -2, 7, 1. But when I write that matrix using these bars, then I'm looking for the determinant, which is a number. And this is how we find it. So let me walk you through how to find this. Multiply the diagonals. Multiply them as well. 7 times -2. And then we subtract their products. So for this particular determinant, it is 17. So this matrix has a determinant value of 17. Okay? So multiply their diagonals and then subtract the products. That's how you find the determinant of a matrix. Now, Cramer's rule gives us another way to solve system of 2 equations or 3 equations using determinants. Recall that a system of 2 equations has solution that is an order pair. So x and y, x coordinate and y coordinate, such that when we plug them back into both equations, they make them true. So Cramer's rule says that we can find the x coordinate by dividing 2 determinants, and we can also find the y coordinates by dividing 2 determinants. You can look at this procedure to determine how to form these determinants, or I can go through an example and I'll show you how. Let's call the coefficients in front of the letter x a1, a2. Coefficients in front of the letter y, b1, b2. And the coefficients, or we call them the constants, on the right side, c1 and c2. In order to solve using Cramer's rule, we need to take the system of equations, of 2 equations, and write 3 determinants for them. And we're going to name each determinant. So the first one that we need, we're going to call this determinant D. And determinant D is formed using the coefficients in front of the letter x and the coefficients in front of the letter y only. So 6, 2, 1, and -3. Next, we're going to form a second determinant, call it D sub x. The determinant D sub x is formed using the constants, using the one on the right side. Okay, so use these numbers. So 2, -2, and then the coefficient that's not part of the letter x. So 1 and -3. Okay. We're going to form a third determinant, call it D sub y. And try to see if you can form the last one by yourself. Use the number after the equal sign. So 2 minus 2. So use these constants. And also the numbers that's not in front of the letter Y. So these are not in front of the letter Y. So 6 and 2, okay? So kind of keep that in mind. So D is just the general, D is just the coefficients in front of the X and Y. D sub X, use these numbers first, and then use the Y coefficients. D sub Y, use that number, and use the X coefficients. So you form D sub Y. We're gonna find the value for each determinant. So the first one is multiplying the diagonals. And then subtracting them. Find the determinant for D sub X. Multiply their diagonals. And then subtracting them. Find the determinant for D sub Y. Multiplying their diagonals. And then subtracting them. That becomes a plus. Okay, so we found the value of the values of the three determinants. We're going to use Cramer's rule to write the answer. So here's what Cramer tells us. Cramer says that the x-coordinate is d sub x over d. And the y-coordinate is d sub y over d. So x is d sub x over d. And the y-coordinate is d sub y over d. Let's go ahead and plug in those values and see what we get. D sub x is -4. And d sub y is -20. So that comes out to be 1 over 5. D sub y over d, 16 over -20, comes out to be 4 over -5. So the answer to our problem is going to be 1, 5, 4, -5. And that's the solution to our system using Cramer's rule for a 2x2. We're going to find the determinant for a 3x3 matrix. So the reason why this is called a 3x3 is because, as you can see, there are 3 rows and also 3 columns. The method we use to find the determinant for a 3x3 will be different from a 2x2. There is some work involved, and I'll show you what each one of these means when we apply it to this problem. So I want to find the determinant for this problem. I need to first just look at the first column. Okay, look at the first column. So what we're going to do is we are going to circle the first element in the first column. And we're going to write that down. We're going to multiply that with a determinant. Now that determinant is found by crossing out the first row and the first column, which is the row and column that's associated with that term. First row and first column. So circle that. If you cross out the first row and the first column, what you have is you have B2, C2, B3, C3, B2, C2, B3, C3, and that's where it came from. So after crossing that out and that out, I get 7, -2, 3, 4. All right, and then what I'm going to do next is I'm going to follow that with a minus sign, subtract, and I'm going to box the second element in the first column, and I'm going to write that down. I'm going to cross out the row and the column that's associated with that element. So cross the second row out and the second column out, and we're left with 0, 3, 3, 4. 0, 3, 3, 4. Okay, same thing over here. Box that, cross this out, cross that out,
what do you have left? B1, C1, B3, C3. B1, C1, B3, C3. And then the last thing we do is we put a star on the last element. And then we start with the plus sign. And we'll write that element down first. Multiply that with, cross out the third row in the first column, 0, 3, 7, negative 2. Now we multiply, we find the determinant for each one of these, and then we simplify it. So this becomes 1 times 28, 28 minus negative 6. This becomes negative 2. 4 times 0 is 0. Minus 3 times 3 is 9. And then minus negative 2 times 0 is negative 2. Minus, I'm sorry, negative 2 times 0 is 0. 7 times 3 is 21. So we have 34 over here. This becomes a plus sign, and that's why it's 34. This becomes negative 9, so that becomes plus 18. And then this becomes plus 2. So the determinant for this problem is going to be adding these numbers together. So 34, 52, 54. Determinant for this particular matrix, this is a 3 by 3. So notice how the process is different from a 2 by 2. It does take some time to do that. Now, Cramer's rule will also tell us how to find the solution of a system of 3 equations using determinants. So very similar to the first, for a system of 2 equations, I will show you how to find the solution using Cramer's rule. What we'll need is we will need to set up four determinants. We're going to call the first one D, call the second one D sub x, D sub y, and then D sub z. That's the 4 determinants. So here is the first determinant, D sub d. D is formed by just taking the coefficients in the first column, second column, and third column, or think of it as the coefficients of the variables. So they are 2, 1, negative 1, 1, 1, 2, and then negative 1, 1, 1, negative 1, 1, 1. Okay, so that's D. We will need to find the determinants for D sub x. So for D sub x, the easiest way to do this is to know that when you are setting up the determinant with respect to x, then you actually don't use that column. You do not use that column. So don't use this column, but replace this column by the constant, by the numbers that are after the equal sign. So start with this 8, 1, negative 2, 8, 1, negative 2, and then proceed and copy down the coefficients of the y of the middle column, or the y variable, and then the z variable. So that would be 1, negative 1, and 2. And then this would be negative 1, 1, 1. There you go. That's called that D sub x. So as you can see, we replace the x column, or the first column, by the numbers after the minus sign. That's it. And then the same thing to the D sub y. And you might have already guessed it. You're going to replace the y column, or the middle column, right, by the coefficients after the equal sign, and that's the difference. So look, if you look at D sub y, see how these are the coefficients after the equal sign? See, so that gets replaced with the middle column, while the first two are for the x and the z. So if I were you, I would, this is the x column, and this is the z column, so copy these down, okay? So 2, 1, negative 1, negative 1, 1, and 1. And then the middle column, replace that by the numbers after the equal sign. 8, 1, negative 2. 8, 1, negative 2. And then we have to set up our last determinant, call that d sub z. And it's the same procedure. We need to replace the last, we ignore the z column and replace that with the numbers after the equal sign right here. Okay. While the x and the y column remain the same. So use the first determinant and copy down the coefficients for the x and y, and then replace this by that. All right. So that's what you do first when you're using Cramer's rule. And then Cramer says that the solution, which is the values of 3 variables, x is found by taking d sub x, divide that by d. Y is found by taking d sub y, divide that by d. And z is found by taking d sub z, divide that by d. Okay, that's it. So here, let's find the determinant for the d. So I am going to do this quickly because as you can see, this takes time. But if you need me to slow down, then you can pause the video. So 2, and then negative 1, 1, 2, 1, minus, and then 1, 1, negative 1, 2, 1, plus, minus 1, 1, negative 1, negative 1, 1, that. And then you do the same thing for this guy, the same thing for this guy, and then the same thing for that guy. So to save us time, what I did is I went ahead and I found the determinants for all of these, which are negative 9, negative 27, negative 9, 9. And we're going to just plug them in here to find the solution. So x equals to negative 27 over negative 9, which comes out to be 3. Y equals to negative 9 over negative 9, which comes out to be 1. And z, which equals to 9 over negative 9, and that comes out to be negative 1. So our solution to that problem using Cramer's rule is 3, 1, negative 1. Cramer's rule is a bit longer than perhaps the elimination method for a 3-equation system. However, it tends to work out without a lot of rigorous analysis. And it actually, even though we know that it has a lot of work, a lot of computation, but with a calculator, you can quickly get these values to achieve your answers.